Well, welcome everyone. For those who know what compliance is, or those who want to learn about compliance, welcome. For those who are just dozing off, again, thank you for coming to my session. I'm going to talk about compliance as code, lessons learned from regulated organization. Quick agenda about DevOps keeps eating the world, compliance as code, infrastructure as code, and continuous compliance. A little bit about myself. So I'm an architect. I worked at Standard Chartered. I worked for Pivotal before. I worked for JP Morgan, Bank of America, ex-alumni, Adobe. I organized the DevOps Days Singapore conference for the 4th year. And I'm the founder of Spring User Group in Singapore. I think we have a lot of changes in the industry, and you probably are familiar with the code software keeps eating the world. In fact, it's more of a DevOps, where developers work with operators to produce high-quality software faster, more reliably, cheaper. And you don't buy DevOps or you get certified. You actually go to the DevOps Days all around the world, and it's more of a community where you share the lessons learned and you learn the practices. So I was very kind of interested when in the keynote, 87%, I think, were of the enterprises that bought DevOps are kind of sad and they're not seeing the benefits. Of course, because you cannot buy DevOps. You cannot make your developers and operators work. You can buy tooling, but that doesn't equate to best practices and principles. So whenever you ask someone what is DevOps, it's very much like the tale of an elephant who goes into a village and there's 4 blind sage, and everyone is touching a part of the elephant and then guess what is an elephant and what does it mean. Well, I think in terms of where you should invest more is stop building this center of excellence around the world and have like a single center where everyone is only that specific region is innovating. Instead, try to build communities of practice where the knowledge is being shared and there's a lot more champions, like the conference that we have here, KubeCon and CloudNativeCon. So DevOps is also an evolving practice, and you should remember that. If you buy into a DevOps 3 years contract and you pay subscription, you're being fooled. Ask for money back. It does mean that you have to look at the way you've been developing the software, and you need to reshape and reorganize the hierarchy and the roles and responsibility. And I'm not just talking about labeling people, BAs, into product managers or project managers into product owners. It doesn't change. You need to do workshops, you need to do roadmaps, you need to do product backlog planning. And this is just like a template that you might want to use if you want to build the software in an agile way. And that's the only way how you can build software, unless you are supporting an old mainframe project. But the good news is that all those COBOL developers, they're sitting and sipping beers or cocktails on a beach, and they work maybe 2 hours a week. So if we're talking about development practices, it's all about iteration. It's all about the feedback loop. You should do and try to do a whiteboard with your team to explain what is the feedback loop. So if we start with unit testing, the feedback loop is within seconds. If you talk about pair programming, it's within minutes. You talk to your pair and you are talking about a specific subject very deeply. If you are doing stand-ups, you do it daily. If you do acceptance, maybe you do it weekly, maybe you do it daily. It's up to you. It's really depend on the industry that you are in. And obviously, if the code or the application doesn't hit production, it doesn't matter. All the other feedback loops, they don't matter because you don't get the most important part, software in the customer's hand. Obviously, you would like to do some exploration, and you would make a very good investment if you would write features and you would focus on the narrative rather than specifications or SOWs or all the legacy paperwork. And one good advice in terms of what you should change in your development lifecycle is you really should focus on testing. And I'll talk a bit more about testing as it relates to compliance. But if your company has the ice cone, where you have very little unit testing and a lot of manual testing that looks like an ice cone, try to switch it into a pyramid where you have a good foundation of unit testing, integration testing, acceptance testing, and very little manual handoff, because guess what? You cannot automate that. So what is the governance manual? So if you work in the regulated industry, it's all about org charts, responsibilities, who is the stakeholder, who is the owners, and there's a lot of other bodies that come into picture. So if you deploy a product, you need to have a country compliance, because you're going to sell a service in a particular country which is regulated by a specific agency. I'll give you a quick example. So I was flying here from London to Singapore, from Singapore to Kuala Lumpur to Shanghai. But unfortunately, London was delayed because there was a thunderstorm. So my flight was delayed. So the first half an hour, they need to give you water. The first 2 hours, they already need to make amenities. And if they were delayed, so you would imagine all my flights were like within 3 hours. So by delaying a full 4 hours, I couldn't already fly. So I had to make amendments to my flight, and I flew London, Shanghai directly. So I skipped home. And that wasn't done because the airline has the best interest for me. It's actually the airline has a policy, and they are fined really ridiculous prices when they don't follow the policies. So compliance as code, what are we talking? So I'm going to give you an example. So I'm based in Singapore. Singapore has a very forward-looking regulator, MAS, Monetary Authority of Singapore. And they have started probably the first ones moving from your PDF documents, where, let me step back, from paper to PDF documents to actual APIs, where you have information about the customers, my info, where I always can check via an API call, who am I dealing? All the KYC, all the AML is being done at the regulatory body. And now they also give you TRMs, which are technical risk memorandums, which give you a documentation in terms of, okay, these are the best practices that you are following. They don't set up a test, but you as an organization, you can parse that reference, that risk memorandum, and parse it into a computer understandable code. And that's what we did. Obviously, because we want to move to cloud, and I think there's a lot of demand all around the world where IT organizations in the banks, insurance, travel, they see a benefit in outsourcing that to a vendor provider. So if you're looking in the challenges, they say, well, what are the application? What are the frameworks? Is it justifiable? Is it enough? And maybe at the fifth one, they will ask, well, what about the security? Can we actually deploy the application onto the cloud? And especially in this region where you have South Korea, you have India, you have Indonesia, you actually cannot deploy it on cloud. You need to think of an on-premise data center or on-premise cloud, how they call it, private clouds, which don't make sense because you don't get the benefit of a public cloud and pay as a utility. You actually need to make a lump sum investment. There's also another caveat. So if you are an AWS customer, they will usually give you, well, we do security in the cloud and there's a shared responsibility. And you look at all the foundation and services that they provide, and you think, okay, I'm probably half there. So if I'm moving to the cloud on AWS, they have me covered. And if you go onto their compliance page, again, they have a ton of ISO documentation and a ton of frameworks that they've been audited. But in reality, and I'm just going to give you in a few slides, it's not particularly true. So what we've done is, like any good citizens, we looked at the best practices. And the best practice at that time was you need to implement AWS config. An AWS config is a way for you to interact with the services from AWS catalog and then check on the state. So when there is a change into a service like RDS or IAM or S3, you can have hooks and you can plug in and then you can start configuring rules. So we started implementing rules because that was, code, and we felt that it's actually the best choice to do it. So configuration management lands on your AWS resources in order to control your objectives. So the control objectives are really the targets that you need to meet in order to pass the audit or in order to offer a service within a country to your desired customers. So this is what we did. We actually talked about it at AWS Summit, and we implemented compliance as code engine. So let me try to guide you. So what we did is we started having this Lambda function, serverless, where we start aggregating AWS config rules. Then we configure IAM policies and IAM roles to give access to a special auditor account to check in on those resources and actually verify if those resources follow the policy. Then we set up a config dashboard, which they've since relaunched, and they call it PagerDuty. Then we have this rule set because we have Standard Chartered is about in 72 markets, so we have a ton of applications. We have, I think, about 2,000 applications. So it's quite unfeasible to check on those manually and verify what is green and what's working. This is AWS config rule. On the right side, you have what is considered the compliance rules. So there's about 27. There's a total of 75, if I remember correctly, which are telling you which are the controls. And by the way, this is all available on the following GitHub and was presented at AWS Summit. But if you look at the code that is needed for verify a multi-factor authentication, so if you're doing banking, it's not only good to safeguard with a password and a complex password, but you also need to have a physical token, or like currently you have a soft token, in order to have multi-factor authentication to improve the security of access to your account. So if you look at the code here, there's a lot of boilerplate, right? Actually, the things that we care about is this line over here and this line over here, which is saying, and your MFA is enabled. The rest of it is boilerplate. Now, remember the diagram where I talked to you about the shared responsibility between AWS and the customers? Well, if you look at what is needed to pass a PCI DSS compliance, which in human terms means if I want to do payments in the cloud, these are the things that I need to implement. And actually, everything is shared, and there's a ton of things that I need to implement as a customer. The only thing that is being granted from AWS is the physical security. They manage the access to the service. So we've started looking at other options, mainly because we needed to implement our private cloud story, then we needed to implement it across multi-cloud. So obviously AWS config wasn't the best choice of tooling that you wanted to do. And we wanted to have more of a spec kind of a language, a DSL, where we can unify and talk in the same ubiquitous language to the compliance and security, rather than holding into those Lambda functions and saying, and by the way, this is the code itself, and here's the paperwork on how to use it. And by the way, we have about 250 controls, and they vary on country to country. So we looked at InSpec, and I will not have the time to demo, but I'm just going to describe you. So the 4 lines above is the same implementation that I need to do an MFA check on InSpec across multiple cloud providers. Then the next one is verifying the access key and the expiration and the creation of the user. And then the last one is a third rule, which kind of checks on the password policies, because you need to have a certain strength for your password. InSpec is an open source framework, is developed by Chef. However, it's actually been acquired from VolcanoSpec. So it's a 6 years old project. It has been authored in Germany by a few compliance officers who work with Deutsche Telekom. So there's plenty of experience in that framework. And I definitely advise you to work with. So what we did next, if we look at we've kind of found the language. So we set up this objective. So we need to meet the regulatory obligation. We need to have statutory and contractual obligations. We need to have authorization, authentication, and entitlements. We need to look at the data confidentiality, data residency, and data sovereignty. Just to explain the difference, data sovereignty is whose data it is. So for example, I'm a permanent resident in Singapore, but I'm doing banking in Hong Kong or in London. So it's a bit more complex. And then the outsourcing obligation and the right to audit. So we've created kind of this pipeline, if you will. So we want to have compliance specifications, which are your DSL in terms of obligations that you want to do. We define our acceptance tests, and I'll walk in a few seconds what I mean by acceptance test. We have a pipeline definition, and we have a controls library. Then what we do is we have these environment definitions, because while we want to be very secure in production, we also want to promote these definitions from dev, SIT, CI, UAT, pre-prod, prod. So we have multiple environment definition. And as you go into very complex banking software, it's actually like a platform. So you treat it as a pipeline, and then every change, it triggers a build and is being audited. Now, I want to go back into the code testing history. So acceptance test is nothing new. If not, it's actually the thing that changed the way we do software. So if you remember, we used to have a separate team called quality assurance who would do just the manual testing. And if you look now, we have a separate compliance, we have a separate audit, we have a separate regulatory. All of those teams working on paperwork. Well, we used to have that back in the days where they would just write, the business analyst would write specification, your domain architect would write some specification, and it would just be paperwork passed in. And really, the change in the industry was when they've introduced TDD, test-driven development testing, where you would collaborate on a feature with the business analyst and subsequently the product manager to understand what is actually needed and what are the tests that need to pass in order to demonstrate that actually the feature is done. And then subsequently, what you had is behavioral-driven development and BDD, where we kind of had the ubiquitous language where we would just write features in Cucumber or anything that is Gherkin style. So ideally, the workflow looks like this. So you have a feature, so you write an acceptance test. That acceptance test fails. Then you start writing a suite of unit tests, which is test scenarios that need to be passed in order for that feature to be accepted. So you start implementing unit test by unit test, and you actually have the reporting, so you don't need to fill clarity, timesheets, or whatnot is your CABs. And then as the unit tests are being done, the feature would be working, and it's green. And if you remember TDD, you also need to have that cycle of red-green refactor. So as you implement more functionality, you need to modularize it to remove duplicates and actually work a bit on the design, because as things scale, your first option might not be the ideal, and you should definitely optimize and tune. So, okay, the next change in the industry, as everyone is moving to the cloud, is that concept of flexible infrastructure. So you have concepts of developer sandboxing, you have cloud dev test labs, which are very much like integration between a bank and maybe a provider, maybe an incubator, or all of those fintechs. Then you have containerization, the concept of moving to microservices rather than monoliths, really extracting services from your T24 or Temenos or big wealth corporate management applications. And you really want to have auto-scaling, because we live in a mobile world, so you don't know where you will have a spike in the access. And obviously, if it's a financial service, you need to think about resiliency. You don't want your banking to go down on the last day of the month when you're paying the salaries. So if you look at the infrastructure's code, there's a great book by Keith Morris, and what he says is, he has a great presentation, which is from the Iron Age, where you configure bare metal, to the cloud age. And the gist of it is infrastructure as code is treating configuration system the same way as we used to treat source code for applications. So you have source code management, you apply TDD, you apply continuous integration, refactoring, and other extreme programming practices, and especially useful for making sure changes to infrastructure are thoroughly tested. So if you remember previously, there's nothing bad if you upgrade your database, right? How many times that triggered a major failover and a call on the Saturday or Sunday? So what we used is we used Terraform. We really like the graph theory behind Terraform, where you kind of create modules and you have a template of your infrastructure. So let's take a simple three-tier application. So you would have your web service behind a web load balancer, you have your web application services, you have an application load balancer, you have your application service, you have a database, and usually it should be with a replica. Now the good part about it is if you use Terraform and apply graph theory, the dependency is being honored, and actually you start implementing from the far back. There's no reason to stand up your web load balancer if your database is not up. And it's very useful when you start applying that flexible infrastructure about which I've talked earlier, because then you can treat infrastructure as code and you can provision those dev, test, labs, and whatnot environments at the snap of a finger within minutes. It's no longer that procurement process. So what we did is we very much looked at Terraform as a way for us to promote pipelines. So we had a template for our development, we had a template for staging and production. And the application code is very much the same. So what you have an artifact, and then the infrastructure is the one that changes. Artifact should be audited and should not change. So if you've done a release in development, you should just push it to production, and you should have your test that verify that the infrastructure abides by the rules that you set up. So if you deploy it in Singapore, it's MAS. If you deploy it in UK, it's PRA. If you deploy it here, I don't recall the name of the regulator, but you cannot deploy it on cloud. It needs to be on Alibaba or Huawei, right? So lessons learned, if I would just summarize, I would say eliminate duplicates, entry of information, and ensure consistency. Streamline approval process to ensure all regulatory requirements have been reviewed. Transparency of information and approval process. Centralized ITO, which is more of a server, infrastructure, farms, service, middleware. Centralized inventory of third party to identify concentration risk. So if all the banks go on to AWS Cloud, I don't think that's a safe bet. We should definitely mitigate the risk and deploy it as many clouds as possible. Centralize information for audit rather than making this 1-year effort where auditors come and then everyone is working on a 3-month process to grab all the information that the auditors ask. You actually have a continuous process where, like, okay, this is the Jenkins build, or this is the inspect test, or this is the Terraform. Everything is there, it's audited. We do it on a daily basis. We build that resiliency and that know-how. Now, if I would go into continuous compliance, here's a code that I am trying to promote. So I'm on a mission to change the way we do compliance. So given a code repository and a set of approved design patterns, when a new valid design specification file is committed and the file is analyzed against the approved patterns, then the design is approved and future releases can go to the pre-production environment or production-like environment. Can you imagine this with a financially regulated environment to actually do these deploys in a day? Because you see all the public releases that financial services are on the cloud, where there's like some risk calculation which doesn't really care about the data, right? So we just spin up compute instances. I'm going to skip here. And again, if you go to cloud, bear in mind that as an evolving infrastructure, or be it KubeCon, be it Kubernetes, you will not have 100% of your applications to be on Kubernetes. Similarly, how it's very hard, and it's been 30, 40, 50 years journey to migrate from mainframe, and it's still the case. You still have your core banking into mainframe. IBM sold that business, but it's still making money out of the consultancy. So you really need to understand and the trade-off between what do you get from an infrastructure as a service, what you're scaling. In this case, it's an operating system. If you go to container system, then you have the images, so you have the scale of a containers and very much like what is my golden image. And if you do it very well on Kubernetes, then your next problem is how do you manage all those golden images, which are, the last count was like 500. Platform as a service, again, it's good to have the application, but then you get too lost into what is actually an application. And function as a service. So the analogy is very much like, what would you define car as a service? It's probably much better if you look at in that way. So if I came here in Shanghai, I didn't bought a house or a garage or a car. I actually called a taxi, or I told the hotel car to pick me up from the airport. In Singapore, it's very expensive to actually own and have a car because they have licenses and you pay, the starting price is about 120,000 for a Renault Clio. So again, it's not feasible. So you much rather go by Grab, Uber, which has been acquired by Grab. Let's skip this. Okay, so that's very much like one of the open source projects that I'm currently working with, Chef, Terraform, HashiCorp, where what we did is we wrote the inspect provisioner for Terraform. So we actually can run inspect profiles onto our infrastructure. We can tag servers saying that, okay, this is an application server Tomcat or JBoss, or this is a Wealth, this is a mobile. And we can start tagging those resources, and actually we can generate a lot of interesting parts. And we worked, and it's actually currently open source and it's working, where we take the Terraform state. So for those who's not familiar with Terraform, it's a HashiCorp DSL, which is abstracting your CloudFormation, Azure IRMs, and what's the analogous for Google Cloud. And basically looks at the infrastructure and then says, I need to have this VPC, I need to have this load balancer, I need to have these resources and service, and then creates the tests. And then you're able to run testing against the infrastructure to make sure that actually what is running in production is what I need to have. Because as you get these APIs, what you need is just a ROG to come in and just trigger an API call, and boom, you're dark. You no longer have a cache management solution on the internet. So what you want to do is, if you want to go even more advanced, is you start looking at Packer, which is another HashiCorp solution, where what you do is you have a builder. That builder packages images for Azure, AWS, Google, OpenStack, you name it. Then you have provisioners. The provisioners can be Chef, Ansible, Bash, whatever you want to how to provision an image. And then you have post-provisioning, and then you build Docker images, VirtualBox, VMware, AWS EC3, and ultimately you build an application image. And then in terms of what you want to do with those application images, it's up to you. It's your process. You have a choice of flexibility or simplicity. So if your concept of a immutable image is actually operating system, middleware, and actually the application artifact, that's very safe in production because there's no drift between development to production. It's an immutable object. It's very much like a container. But if you apply it to a OpenStack or to a VM onto EC2 or AWS, that's even more powerful. Or you can do Cloud Init, where you provision everything and you still call it immutable. But then it's up to you how you do the trade-off. And I'd like to have a few more slides. Let me skip this. So why do you want to automate? Well, basically, so back to the discussion about my flight here to Shanghai. When I tried to call the call center, which was in India, and I tried to explain all of the things and what's happened, well, they follow the policy. I didn't get the result because they just have a system that gives you an access. Now, if you can codify that system, it's no longer up to an interpretation. So if I call John Sam, Michael, Rajit, they all interpret that policy, and you might have different results depending on whom you have on the call, how lenient or how stringent they are. That's not the same when you have a system. You call a system on a Friday, on a Monday, on a Christmas, is the same result. It's repeatable, it's auditable. It doesn't matter if I had my lunch, if I had my tea, if I am rushing to pick up my children. So you should set up these guardrails. You have continuous monitoring, you have continuous assessment, you set up audit and compliance, and more importantly, you go back to the original reason. Why do you build software? It's not just to build a paperwork process around it. It's very much about change. How do you manage change? And change not just in computer systems, but more in terms of how do I educate my customers? So if on 10 years ago, everyone was very accustomed to go to a branch, and now you give them a mobile phone and they are expected to do all their banking from that mobile phone. But then you go to, so if you're Singapore based and there's an OTP in Singapore, you go to London and immediately it's not recognized because guess what? You don't have access. The firewalls are not configured. There's a lot of things that we need to mature as an industry in terms of the controls library, the frameworks, and more importantly, how do we treat compliance going forward? So for me, it's the same as I've seen probably like 15 years ago, where we no longer have a quality assurance team that is dedicated to doing testing. Testing has become part of the core team. Everyone is doing testing. The same goes about compliance and governance because they are setting up rules for you as a customer. So it doesn't matter if I work in financial services, I'll still have to buy an insurance product or a travel or a ticket. So by investing into automated tools, you make sure that those policies are being respected and you as a customer are given the rights. So with that, these are my contacts, it's my LinkedIn, and down below is my Twitter handle, at Sergiu Bodiu. Thank you very much. Do we have any questions? Doze over compliance. Well, how many actually speak to compliance or have anything to do with compliance? Okay. So this was an intro talk for the others. I hope you've got a lot of good details. The slides are being published onto the sket.com, so you can download it from the link in the talk in the agenda. Again, I would like to give you the message that it's about improving the flow of customer value, right? So it doesn't matter if you do CI/CD or you do Jenkins builds. Nobody pays you for how many Jenkins builds you've done successfully or how many containers do you run. It's really like, do you have a working software? Does it work by the specification? Does it meet the criteria? And do you follow the audit? So make sure you do continuous integration, continuous deployment, release management, and automated testing. And just improve. Thank you very much.